Welcome back to another video in the Introduction to Cybersecurity series. In this video we'll talk about authentication. As mentioned in the previous video, when we were talking about secure design practices, least privilege is an important principle. It means that you only get access to those resources that you should get access to in order to accomplish what you're authorized to do. But before I can assign privileges to someone, I have to know who they are. And that is the goal of authentication. So in authentication, we try to establish the identity of a person or another computer system so that we can assign appropriate privileges to them. Authentication is a two-step process. It starts typically with a claim of identity, where I could go out and say, "Hello, my name is," and so I have made my claim or my assertion of identity. Next, I need to prove my claim somehow, and of course that is the verification step. And when I put those two together, identification, the claim of identity, the assertion of identity, paired with verification, the credential that proves that my claim is correct, can I see that I have been authenticated as a user. The identification stage can take many different forms. I could go up to you and tell you who I am. But in a computer system, talking to a computer makes people look at you funny. So we typically give people a prompt, a username prompt. But we ask them to type in a username or an email, or in any case some form of unique information that identifies them as a person. But again, still, that's just a claim of identity. There are different ways we can do this. Some systems do it through literally typing the username. Others might have you swipe a card that has information imprinted on it or scan a document. It really doesn't matter. All we're doing is often a public display, a public exchange of who we are, a claim of identity. The second stage, the proving of who we are, that of course would not be necessarily a public exchange, because someone who is eavesdropping could then just take that and run with it as well. So what we distinguish is that there are different ways by which we can identify ourselves. Sometimes we call those factors. The factors are, the main factors I should say, are one, something we know. So it's a shared secret, shared knowledge. And so there's a problem with that right from the get-go. A shared secret is not a secret at all. If I know something and you know something, we have a shared knowledge of it, but it doesn't mean it's a secret anymore. The information is still confidential, but it is no longer secret. So that's one, something we know, shared secrets. The second one is something we have. If I have a token, maybe a badge or a passport or a special card or a digital certificate that I can show you that proves that I am who I claim to be, then that could help in establishing my identity as well. The third factor is something I am, biometrics. It could be something that is tied to me as a person, that cannot be moved from me to another person. That might be speech pattern recognition, it may be fingerprint or finger swipe recognition, it could be iris recognition, it could be facial recognition, it could be all kinds of things. That is something I am, and that could help establish my identity as well. And then lastly, sometimes used is the somewhere I am, a location-based credential. And whether that is through a GPS-based GeoIP, or whether it is about physical presence at a given computer at a given time, it doesn't matter. It all puts an individual in a particular place, which hopefully that presence there adds to the plausibility of that claim of identity. The process of claiming an identity and supporting that claim by providing a credential, evidence, that's what we call authentication. Let's discuss each of these factors in a little bit more detail. The most common factor used by itself is password-based authentication, or identification by shared secret, knowledge-based authentication. It's also by far the most weak one. It relies on people's memories, and memories are notably flawed. It also means that there should be information that is known only to an individual. In today's day and age, with all information pretty much being at the fingertips of anyone who knows how to use that information, knowledge-based authentication is kind of a farce. It is not effective. It's fairly easily bypassed, and although it may seem cheap and cost-effective, the reality is that because of the relative weakness of password-based authentication, there's hidden costs that aren't immediately obvious. Whether that is cost for supporting end users who no longer remember their secret and have to re-establish their identity with the system, or whether it is costs related to data breaches or investigations. Password-based authentication, therefore, by itself is a fairly ineffective protection. It's also a fairly expensive protection, but the main benefit is we have been teaching people for decades now that usernames and passwords are the way that you identify yourself to a computer. And that means there's a very low hurdle of adoption. People already know how to deal with usernames and passwords. It comes natural to them, even though it's really an artificial way of doing it. Everyone has been trained for decades on how to use usernames and passwords. And therefore, it is fairly user-friendly. People know how to sign up, people know how to type their password, people expect that they have to reset them every now and then. All of those things are known to most people. And so that's really the only benefit of passwords, is the fact that people are used to them and know generally how to deal with them. But from a security perspective, passwords are not a great way to go about things. Hopefully, what we see is that passwords are not stored on a computer in plain text, because then anyone who has access to that computer will be able to find out what my password is. Instead, what we try to do is use all kinds of encryption techniques. One of them shown on the slide behind me is a very weak way of doing it. It's the old Unix file system, the Unix operating system way of doing it. But the point here of this slide is to show that I am not keeping the password in plain text. I am somehow obscuring what it is. The problem is that however we do that, whether it is in plain text through a simple hash, or we use some sign of encryption, or even if we use specifically designed algorithms like bcrypt, passwords, once they have been recorded, can be recovered. Doesn't mean it's fast, but it does mean it's possible. And as a result, even though we might think we have a shared secret only between the system and us, in reality it is between the system and us and everyone else who has access to that system. And so again, one strike against the use of passwords. The second factor is something we have, a token-based authentication. And that means that I have something, a physical device in my possession that I can either show to another person or show to a computer system, and just the mere fact that I have the device means that I must have gotten it through some trusted means and that it supports my claim of identity. We see these tokens coming in a number of different ways. The two main ones are memory-based devices and smart devices. A memory-based device is something that stores static information. You can think of it as, a passport or a driver's license. You can't really interact with it, but you can show it to someone. Smart devices, that are devices that have some form of logic built into it and that we can interact with. So memory cards can store, but they cannot process data. For example, most bank cards in the United States are memory devices, although it is rapidly changing, where bank and credit cards have chips on them that are basically small microcomputers that can be used in the authentication process. In the EU, what's a lot more prevalent is contactless cards, which work on similar principles, but they also have some form of logic in it. There's a couple of disadvantages associated with the use of tokens. The first and most obvious one is that if you don't have your token, you cannot identify. Identify. So that means that we have a usability issue. It's not as user-friendly as passwords, where all you need is you. Now I need myself to identify and do my claim of identity, but I also need the device to prove my claim of identity. So I need some form of a special reader that can process the device, which means I can lose them, and which means I have to replace them. And with that alone comes costs and logistics that are, at scale especially, not always trivial. Users don't like to have to carry things around, especially if it doesn't benefit them directly. It is bad enough that we have to carry keys. Now we have to carry a computer key as well. The main disadvantage, though, with these memory devices is it is very easy to copy them. The equipment is readily available on the internet, they're cheap to replicate, and all I need is your card in my hand for a couple of seconds to read it, and then I can clone it on my leisure. And that means that the added protection given by having the token is very limited. And lastly, it needs special infrastructure on the other side as well, and that makes them expensive to operate. Smart devices have a microprocessor built into them. That makes them more expensive, but it also makes them harder to copy. Still possible, but not as easily as a memory device. And so that means that all the same arguments hold for smart devices as they do for memory devices, with the exception that copying is a little harder. We can use more advanced types of cryptography to really protect the identity of a user, because now we have a small but still effective computer on the card. But it also means that they become more expensive and that they are more complicated to use. At this point, there's really no reason not to use a smart device if you're using some form of token-based authentication. And whether that token is something that is a challenge response token, where the computer sends something into the device which then has to compute it and present a response that only can be generated by that particular device, or whether it is a time-based token where a numerical code changes every 30 seconds, for example, based on information that is coded uniquely to that card, it doesn't really matter. At this point, there's no reason not to use smart devices over memory devices, other than, of course, companies who already have invested heavily in infrastructure that relies on memory devices, because, again, the infrastructure needs to support the device that you're using. The last category is biometric, something you are. I mentioned those before. There's a lot of them, and they are tied to an individual, and they cannot easily be removed from that individual. And we use those on a very regular basis. iPhone users are used to be able to get their phones unlocked with fingerprints or facial recognitions, and yet there's other concerns that go with that. For example, I can't change my fingerprint. I have 10 unique ones to choose from, but once I've used all of them, I'm kind of stuck. And so that's an issue. It's privacy sensitive information. It's information about me. It's about as much about me as it can be. So maybe I don't want that information just laying around everywhere for people to get a hold of. Biometric systems also require special equipment, although that is getting better with especially fingerprint recognition and facial recognition scanners. But if I'm looking at things like iris scanners, most people aren't too thrilled with having to shine a laser into their eyeballs to authenticate themselves to a computer. The main difference, though, between biometric-based authentication and other factors of authentication is that is that a biometric is not a hard decision, true or false, yes or no. It is a probability, and it needs to be tuned. Where in password-based or token-based authentication, I have the password or I don't. I have the token or I don't. When I identify with the biometric, the answer is, well, it's 65% certain it is you. And then it's up to the computer system to figure out if that is enough, yes or no. The problem is that I need to tune them, and that means that if I want to be more certain, so I want to reduce the chance of false positive identification, I can do that. I can make my scanner a lot more sensitive to only accept people when they're really sure that it's them. The problem with that is that I'm also increasing false negatives with that. I'm also going to now reject people who are indeed who they claim to be. And so to figure out where that tuning needs to sit, how picky I want to be, how certain I need to be that this user is indeed who they claim to be, is something that is an extra step that you need to take with biometric systems that you don't have to take with the others. And that depends on the environment. If I'm dealing with, let's say, prescription drugs in a non-urgent setting, then maybe it's okay to somehow reject legitimate users every now and then, as long as I make sure that only legitimate users can get to the drug cabinet. Maybe the same thing is true for weapons lockers. I don't want too many false positives on there, otherwise someone who is not a legitimate person could open those lockers, rather than only the people who should. While on the other hand, it might be a little less important, where it is primarily a control meant to keep attacks of opportunity out of the way, and in that case I can deal with an occasional false positive. Whatever the deal may be, those biometric systems need to be tuned. What we really want is not to be reliant on a single factor of authentication. What we want is multi-factor authentication. We want to be able to say, okay, let's ask for that password, but also ask for a token. So I'm going to ask you for your username, your claim of identity, your identity assertion. I'm going to ask you for your shared secret, but that's not enough. I will also want to see your token, or I also want to see your fingerprint. And by doing that, I create much stronger forms of authentication. It is important to realize that I want to have two separate factors or more in my authentication strategy. I don't want to just repeat the single factor multiple times. I don't want to have to first type in my first password and then my second password, or maybe a password and a PIN code, which is also a password. That's not effective. But once I start combining factors, I can be reasonably or even very sure that whoever passes the authentication challenge is indeed who they claim to be. That's it for this video. In the next video we'll explore a little bit, at least from a high level, how we can attack password-based authentication systems. And then in the next video we'll talk about single sign-on systems.